Start with our DSA journey with this amazing DSA visualizer by ChaiCode, dsa.chaicode.com. Use this link to get a 7-day free trial. Okay, so let's start with the DSA. So today's question is tapping rainwater, water held between bars of varying heights. Given an elevation map of bar heights, compute how many units of water can be tapped between the bars after rain. So this is 2, this is 0, this is 4. The water can be stored here. Again this is 1, 0, 3. Water can be stored here. Okay. So if you go to the question, there is a beautiful visualizer actually. Okay. Just so just see this. See this visualizer. This is all the bars. This is the empty space between the bar. The water stored in between these empty places. So we have to calculate how many unit of water can we store between all of these bars. Okay. So let's just take the array first. It would be 2, 0, 4, 1, 0, 0, 4, 1, 0, 3, 1. Okay, so this is the array. So how this water got inside this bars, or when the water got inside this bars? The water only goes inside the bar if we have bars like this, and in between maybe a small bar or maybe nothing. So in this place the water is stored. Here is the largest bar, here is the largest bar, and in between this is the portion where the water is stored. So we have to find it. Okay, for this what can we do? Just think of it like we need two bars in two sides. Okay, so what if we just calculate all the bar at the left and the bar at the right for a specific index. Okay, so suppose this image, like, let me draw it again. So this, okay, so suppose this is a bar, this is a bar, this is also a bar. This is the ith index at the point where we are standing. It is the leftmost highest point, it is the rightmost highest point. So water should be here in this portion. So just calculate this and remove this value for every index. Remove this value. Calculate the left max, it would be like left max. Calculate the right max and remove it with this, because this is the height which you have to remove. Okay, let's first simulate this. Simulate it here actually. For every index, okay, for every index, suppose this is the index, we have to find the most leftmost part, highest left in this portion and highest right in this portion. Suppose for this is the index I. For this index, for this value, just get the highest from here, get the highest from here, get the minimum of both of this and remove this. Okay, so just come here and see the visualization. Okay, and what should be our formula? First discuss. And what is the leftmost here? This is 2. What is the rightmost? This is 3. So for this index our water capacity would be minimum of h of, or rather say left max comma right max minus h of I. Why? Let's do it. Like, we take the minimum of the left and the right and remove this I. Okay, so suppose this is the tower, this is the left portion, this is the right portion, and this is the ith portion. So this is I, this is left max, and this is right max. Okay, so this is actually the portion where the water should stay, because on this portion we cannot stay the water, we cannot store the water because we don't have this anything here. So this is the minimum one. So we, for this reason, we just take this minimum part, just take this minimum part and remove this I, so that this portion only take place. And this is actually the formula of our index I. This is the formula. Okay, let's go and simulate it. You can see the formula here. This is a max left and max right minus h of I. Okay, so for the index I, starting from the zeroth index, for the index 0, the left max is 2 and the right max is 4. Okay, so what we got, okay, here, like, for this index all of this is left, so we take this only this index so that we can get it, and for all this portion this 4 would be the highest one. Okay, just take the minimum between them. Okay, and remove the height, which is 0. And why we do a max here? Just because if any time we get any value that is negative, we don't add it, we just add a 0. So in this case also the left max is 2 and the right max is 4. Okay, so calculate the minimum. Minimum is 2. So minimum minus height of I, it is 0. What is the minimum? 2. 2 minus 0, so plus 2. Okay, then go to next. The left max is 4. The right max is also 4. Okay, for this index. So this will be like added to 0, because 4 minus 4, 0. Then we go to the next index. For this left max will be 4. The right max will be 3. So the minimum would be 3, and this is the area which where we can store the water. So the ith index is, we just minus the ith index. For for this 0, left max is 4, right max is 3, the minimum is 3, we store the water. Again, for this index, left max is 3, right max is 3, it is 3, 3 minus 3 is 0, so nothing. Then again it is 4, the right max is 1, so minimum is 1, 1 minus 1 would be 0, so nothing. We get our total element. Okay, just give it a shot. Function, it will take an h. Okay, so take a total that is initialized with 0. So for I started with 0 to n minus 1, for every index calculate the maximum left. Maximum left. Okay, for how we calculate max of h of 0 to h of I. So if this is the index, the 4 is the index, then we calculate the left max on this portion. on this portion. Okay. Similarly, calculate the right max, which is nothing but max of h of I h of n minus 1 till the last index. Till the last index we get it. Let's just now calculate the capacity which we store here. What or the value? The capacity or the value would be minimum of max left, comma max right minus h of I. Okay. Now increase the total max of 0, comma capacity, because this value can be negative, and at the end return total. So this is our function. Just evaluate it. It is the brute force approach. Yes, we nailed it. Now let's go to here and write the code for this. Right. Okay. This should be the next line. This should also be the next line. Okay. So this is our code. First take the size of the height. Take the size of the height. Then just take a total. Start a loop from the start to the end element. Take every element and first take the max left. Okay. So how could we? Okay, let's take the max left. So for every element we have to calculate the max left, max right. Okay, so take it here. Max left is of 0 and max right is the last element, nums of I minus 1. This is the leftmost in element, this is the rightmost element. Take should I just put it outside? Because every time it will initialize. Yes, we have to put it outside because every time we don't want to initialize it. So take a j from the starting and just iterate through that while the j is less than I till that index. Just take the left element, max of max left, comma nums of I. Take the maximum element and increase the j. Then point the j to I, and now calculate the max right while j is less than n. Right equal to max of max right, comma nums of I. Okay, or it is a mistake, it should be nums of j because we are doing on the jth element. So j minus minus, or sorry, rather than j plus plus from I to index. Okay, so now just calculate the capacity or the cap, which is nothing but minimum of left, comma x right minus height of I. Okay, and total class equal to max of 0 comma capacity. Okay, and return the total. Yes, this is the code. Just take. Okay, why nums? It should be height. Why nums? It should be height, and this should be not I minus 1, this should be n minus 1. Okay, we are having wrong answers. Because we have to take the same element also sometimes. But where is our mistake? We just take the size. Okay, till j less than I, we just take every element, put j equal to the ith index, go till the last element and increase. Okay, minimum left max and right max. Okay, this should work. Should work. This should work. What is the mistake? What is the mistake that I am making? I think I am making some mistake in this loop. Uh, Let me give a try to debug it. Yes, so got the mistake. We have to initialize this inside the array, inside the loop. Okay. This should be the same index. This is only because we are taking, like, we are taking, okay, sorry. So, just a minute. So, in this index, we want something that is greater than this always. Because if something in the left never greater than this, or something in the right never greater than this, then we cannot store any water for this, for any single value. For any single value, if nothing in the left is greater than the index and nothing in the right is greater than this index, we cannot store the water inside that index. So for that reason, for every one we have to just initialize with it, just run it. It's working. Let's submit it. Okay, it's got an TLE. Yeah, it's big of n square solution, so it's okay to have a TLE. So move to our beta approach. Okay, so in the beta approach, what we are doing, we take another two arrays. One is a prefix, another one is a suffix. Why? Let's check it first. Just copy this array. Okay, so first. Okay, so first, uh, just try to place two array. One is maximum at the left of every index, another one is maximum of the right of every index. Okay, so this is two. Okay, so just so in this array, the first index is 2. Go to second index 2 and 0, which is maximum 2. Go to third index 2 0 4, which is maximum 4. Go to fourth index 2 0 4 1, which is greater 4. In the next index 0 2 0 4 1 0, which is greater 4. In the next index 2 0 4 1 0 3, which is greater 4. In the last index, which is greater 4. So this will be our maximum left. All the left value which are maximum. Okay, so similarly take another array and calculate the maximum right. Okay, so it okay, calculate the maximum right. Okay, so for this case, traverse from the backward. So 1, which is minimum 1. Okay, go to the front. So 1 and 3, which is maximum 3, go to the front. 1 3 0, which is maximum 3, again go to the front. 1 3 0 1, which is maximum 3, again go to the front. 1 3 0 1 4, which is maximum 4, again go to the front. 1 3 0 1 4 0, which is maximum 4, go to the front. 1 3 0 1 4 0 2, which is maximum 4. Okay, this is our maximum right element, all the maximum right element. So now we have, okay, so just remove it. So for every index we have these three value. We have the index value, we have the maximum left value, we have the maximum right value. We have the index value, maximum left value, maximum right value. Remember the formula. We have the maximum left value, maximum right value, and the index value. Just put the formula and get the index. First we have to store these two, and then simply use this formula for every index. For every index, like this should be the case. Maximum right of I. Okay, we got our maximum left, maximum right. Take the minimum of it, take the index of it. So this is H. This is the same formula, just we use two arrays. Just use two arrays. One is similar as prefix, another one is similar as suffix. Just to take all the maximum values. Okay. So first let's visualize it. We just take, okay, let's say this is max left. First calculate all the max left. It is 2. Then we go here and check for it that is 0 or 2, which is more. So 2 0 2 4, which is more, 2 4. Here also 4 4 4 and 4, because all are maximum, and we get our maximum left, that is 2 2 4 4 4 4 4. You can see it here, 2 2 4 4 4 4 4. Then go for the maximum right. In the blue line we have the maximum right. This is 1, this is 3, this is 3, this is 3, this is 4, this is 4, this is 4. We got our maximum right. 4 4 4 3 3 3 1. 4 4 4 3 3 3 1. Now traverse the array from the starting the input array. In the 2, in this index, 0th index, the maximum L is 2, the maximum right index is 4. So take the minimum of these two, that is 2, minus, remove the index, that is 2, 2 minus 2, 0. So add 0 to the total. Similarly, go to the next index, 2 is the maximum left, our maximum right is 4. So calculate it, it would be minimum is 2 and the value is 0, so 2 minus 0, that is 2. Go there. Okay, let's just do it here. Okay. For this first index, we got 2 and 4, which is minimum this 2. So 2 minus 2, that is 0, plus add it. For this second index, 2 4, which is minimum this 2. So 2 minus 0, so that will be 2. Again go to the next index, 4 4, 4, take any of this, 4 minus 4, 0, plus 1, which is minimum 3 or 4, 3. So 3, so this 3 minus 1, that would be 2. Okay, so go to this next index, which is minimum this 3, this 3, 3 minus 0, plus 3. Go to the next index, 4 3, which is minimum this 3, 3 minus 3, 0, 4 1, which is minimum this 1, so 1 minus 1, 0. So the total answer would be 2 plus 2 plus 3, that is 7. Also, you know the reason for this number. Also the date is here. Everything is coincidence. If you go to the next index here, the value will be 0. If you go to the next index here, the water would be 3. So we add to this total, we get 7, and we get 7 here. Then we again go here, the values will be 0 and the total will be 7. Always the reason for it. Let's write the pseudocode. Take a function which take h and take two array. One is max l, an empty array. At the starting index of this maximum should be initialized with the first index of the h, because nothing is previous the h. Or sorry, not, this should be 0. Okay, so now just take a loop from I starting from 1. Why 1? Because you already take the 0th element here, so you don't need to take this, to n minus 1. Okay, so for this case, take the maximum L of I. For this index, maximum will be max of maximum L of previous index, and this index value, which will be the maximum, we take it. This is the simple maximum formula. Okay, similarly take maximum right, which is this empty array. First put the last index, n minus 1 should be equal to h of n minus 1, the last index, because we are taking this array from the right, so the last index. So for I, take it from n minus 2 down to 0. For every index checks, max of r of I is equal to maximum of max of r of I plus 1 comma h of I. Max of r of I equal to max. So here we take the previous index because this is the left, we are traversing this way from 0 to n minus 1, but for this maximum, right, we are traversing from n minus 1 to 0. That's why it is I plus 1. We take those. Now just calculate the total, like total initialize with 0 and take a loop for I starting with 0 to n minus 1. Just calculate the capacity, which is minimum of maximum r value comma maximum of left value. We just take it minus h of I, and the total plus equal to minimum of 0 comma capacity, the total capacity, and return the total. Okay, return the total. It should work. Let's see it. Okay, not in this should be size of n. The second loop have a typo. Okay, instead of 0. eh, okay, okay, I don't know this. So this should be max, and somewhere I make a mistake. Max L, max R, max R, max R. Okay, this there should be an R. I think this is the problem. Yes, it works. Let's go and do the better approach here. Code the better approach here. Okay, okay. Let's int n equal to dot size. Okay, now take and array, like take a vector which is in type of max of L, and it should be of n size. It should be of n size. So max of L of 0 is equal to height of 0. So now take a loop from 1 to n for equal to 0, I less than n, I plus plus. Just do it, and max L of I equal to max L of I minus 1, and it should be start from 1 because we already take the case 0 here and we are taking I minus 1 here. So it should be height of I. This is the maximum, and vector int maximum of R, also an n size. So max of R of, let's take this vector here, should be easier. X of n minus 1 equal to heights of n minus 1. Put the last index, then start a loop from the last int I equal to n minus 2, I greater equals 0, I minus minus. For every element, check the maximum R of I equal to maximum R of I plus 1 comma height of I. Okay, so this is the I plus 1 because we are taking always the next index, because we are traversing it from the end, and here we traversing from the start to end, here we traversing from the end to start. Then loop, then put another loop, I equal to 0, I less than n, I plus plus. For every element, calculate the capacity, which is minimum of max of left of I comma max of R of I minus height of I. Okay, so the total is plus equal to max of 0 comma capacity. So just return the total. Okay, oh, we don't initialize the total. Okay, we don't initialize the total at the starting. Why? Spelling mistake. Lord, let's see it is passed or not. Yes, it passed. It works. Now let's move to the most optimal approach, that is our two pointer approach. And in this case, okay, in this case, the time complexity is big O of n because it just take big O of n. It is also taking big O of n, and this is also taking big O of n. So it will be big O of n plus big O of n plus big O of n, that is big O of 3n. So we can neglect the 3 and it become big O of n. And we are using two vector of n sizes. So the space complexity would be big O of n plus big O of n, that is big O of 2n. We can easily neglect the 2 and the approximation would be big O of n. So the time complexity is big O of n. The time complexity is big O of n. This is the time complexity, and the space complexity would be big O of n. Okay, so this is the solution and it works. Let's now move to the optimal solution where we don't use this space. This space will become big O of 1 in that solution using two pointers. Okay, so let's take it. So, or just visualize it, it will be helpful. So take two pointers as usual, one at the starting, another one at the end. Okay, okay, at the start, at the end. Take, okay, then which is lower, and initialize all your left max, right max and total with 0. Everything with 0. With the left max, right max, total, everything started is 0. In this left and right, which element is smaller? The right one. The right one. Okay. So the right one is smaller and the left one has the bigger size. We need to first check that we have the right max or not. So we just come here and check the right max is 0, and now for this value we increase our right max. we increase our write max. Okay, we just increase our write max to 1 or the value. Now we just do a write minus minus. We just go here, which is smaller, the left one. The left one is smaller. So for this case, the bigger side is on the right side. We have to settle it down. The bigger side on the right side, the left side is smaller. So we got our minimum element. The minimum we are taking here every time. We are taking this minimum here. We got the minimum between left and right, which is minimum, the left one. For this first check the left max. Okay, we update our left max by 2. Now increase the left. Okay, now for this, left is 0, right is 3. Which is smaller? The left one. And does this left value is greater than left max? No. That means we can store water here. We can store water here. You can clearly see we can store water here. So what would be the water storage value? Left max minus the left value. Left max minus the left value, that is 2. We add it to the total and increase the left. Now which is smaller? The right one. So now check the right max. The right, we need to update the right max here. We update the right max. Okay, we decrease the right. Now check which is smaller. The right one is smaller. Okay, does the right value is greater than the right max? No, it is 0 and it is 0 and the right max is 3. So we can store water here. Okay, so how many amount of water? Right max minus the right value or the height of right. Same, right max minus the right value. Now again decrease the right. So which is smaller? The right one. So it is greater than right max? No, that means we can store value here, water here. So 3 minus 1, 2 unit. 2 unit. So here is 2 minus 0, 2 unit. Here is 3 minus 0, 3 unit. Here is 3 minus 1, 2 unit. So total 7 unit. Okay, we increase it, we decrease the left and we decrease the right, and it's pointed to the same portion, and we stop it. Let's write the pseudocode here. Take a function which take a h, take the left starting from 0 and write this to our pointer as usual in two pointers. Let's go to the left max. Left max, it start with 0. The right max, it start with 0, and the total is also start with 0. Okay, so just loop through it while left is less than right, the two pointer condition. Okay, take the minimum between both of them, the left and the right. So if like, okay, age of left is less than age of right, then for this case we have to check first if the value we are getting in the left is greater than the left max or not. Okay, first check it. If age of left is greater than left max, if this is, update the left max and the left max will become age of left. Okay, or else 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 that means the left max is greater and the current element is lower. Like similarly in this case, the left max is 2, the current element is 0. So we can store water here. This is something like, this is 2 and this is 0. This is 0. So we can easily store water here, and how much? The I and the left max. Just remove minus both of them. So the total would be plus equal to, we just add to the total, which is left max. Okay, left max minus the left value, left max minus the left value, and we increase or not, every time we have to increase the left. Okay, similarly, so this is the else condition of this if statement. That means the right element is now smaller. So for this case, okay, this is good. For this case, first check the same if the right max is smaller or not. If h of uh, right is uh, h of right is greater than the right max. So for this case, update the right max. Update the right max. That's mean uh, right max equal to h of right. Okay. Now for the else case, that means the right max is not greater. Okay. So the right max is greater, the value is lower. Uh, Clearly see here, like this is 3. Suppose this is 3 and this is 0. We can easily store water here. So just store water at the total plus equal to the right max minus h of right. Right max minus h of right. And for every condition, just decrease the right. Just decrease the right and return the total. Okay, let's evaluate it and see. So here what we are doing is we just uses two pointer to check the left max and the right max and just get the value in between them, so that, okay, something went wrong. Let's do it again. Okay, this should work. We can start writing the code here. So this is the most optimal solution. So this will be here. Uh, this will be there. Okay, this is there and this is there. Now it's worked perfectly. Let's see it here. Okay, we nailed it. Same. Just take the int n equal to, first take the height, the size of the height, then just simply took all the pointers here. Left, okay, left starting with 0, the right starting from n minus 1. Take the left max equal to 0, right max equal to 0, and the left max, right max, and the total or the answer equal to 0. Initialize with it. Okay, now take the two pointer while loop, while left is less than right. Okay, for this case, take the minimum first. Take the minimum between left and right. Okay, so if height of left is less than height of right, so we take the left as the minimum. For this case, first check the rightmost value. Check of date the rightmost or sorry, not rightmost, leftmost value. Okay, so if it of left is greater than left max, for this case, or update it here, height, okay, high no, left max equal to height of I or height of left simply. And if we get a greater value, just add it to the total plus equal to the left max minus height of left. Okay, and for every cases, just increase the left. Else in else case, update the rightmost right max. So if height of right is actually greater than right max, then just update the right max, which should be height of right. Similarly, in the else case, calculate the total plus equal to right max minus height of right. Okay, and decrease the right. Return the total. So it should work. It's too big. It is working. Okay, we cleared it. So here we just run a while loop. So the loops takes runs in big O of n complexity, and only one loop we are running. We don't use any extra space. So the time complexity and space complexity both will be big O of. The time complexity will be big O of n, and the space complexity will be, we don't use anything, so big O of 1. Okay, this is one of the most optimal to solve this question, tapping rainwater. So this is the pseudocode, this is the actual code, this is the visualizer, so the solution, and we are done with the 2 pointers. Every question on the 2 pointers we completed it. So next, the array and hashing we'll do it another time. Go and use this platform with this following link. This link I just pasted here. With this link, just go use the platform with this link, and you will get a 7-day free trial. Okay, go and use it. This amazing chai visualizer, chai DSA.chaicode.com. Thank you very much.